Here's a mock-up of a data model that's been developed using traditional techniques. Three things wrong with this one really. The first is it looks pretty complex. It's unapproachable to a business person. The names don't mean anything. If a business person looked at this, they wouldn't instantly recognize the things that the model is supposed to represent. And it's pretty detailed and complex, lots of lines crossing. It looks like a piece of knitting. And this is the very thing we're trying to overcome. The unapproachability is something that we're trying to get rid of. So let's take a look at how we might go about doing that. And here it is, the simple three-step how to convert a model slide. Two steps of which are pretty simple, and one step is pretty difficult. So I'm going to look at that in more detail. Basically the three steps are this. The first one is to turn off as much as you possibly can in the modelling tool that you use, so that the relationships particularly, but the attributes and entity names as well, have as little technical information on them as possible. The second is to remove time, and that involves three things in itself. Firstly, removing intersection entities. The second, removing attribute history, and the third, removing relationship history. I'm going to go into a little bit more detail about how you do that in practice with an example in a moment. And then the third thing is to make names real-world names. So no text on your model at all should be anything other than a recognizable name that a business person would instantly relate to. So there you are, three very simple steps. Number one and number three should be something that you can do almost as a matter of course, and I'm not going to dwell on those any longer here, but the second item in this list, removing time, is the one that will cause most trouble, and so that's what I'm going to go into a little bit more detail about now. Before I do that though, let's have a look at the end result of converting a model of this sort. So here's the end result after conversion. It'll be simple, less clutter because there are fewer boxes. I've made the relationship lines mostly parallel just to ease the style of reading the diagram, and the names on there are all instantly recognizable business names, something a business person would feel at home with without any training. Now the tricky subject of removing time. Let me introduce an example, and then we'll go through how you would model that, and then using conventional techniques with the time included, and then we'll take the time out to show how that works. So I've drawn a map of the United States here, and in our imaginary company the states have been separated up into a number of sales regions. So I've got 4 sales regions, each of which has got a number of states in it. And over time what happens is these regions change. So a new sales director comes on board and decides that the Carolinas ought to be part of the South region rather than part of the Northeast region. So the states that are in this particular area here used to be in region 3 and now they're in region 4. So over a period of time each of those states has changed which sales territory or which sales region it's in. So let's look at a model to represent that situation. We've really got two major concepts, that of a state and a sales region. And then in a traditional modelling technique we would have a third entity which is the inclusion of the state in the region. So each of these entities represents the inclusion of a particular state in a particular region for a particular period of time. So the attributes of this inclusion entity will be a start date and an end date. So we may have a number of states and a number of regions. Each one of these inclusions says this particular state is in that particular region for this period of time. That's how the traditional model would look. Let me just clear some of this clutter for you so it's back to the model. And there will be a number of these intersection entities, as we call them, because they represent the intersection between these two entities. In a very simple way, if this intersection entity only exists because of the period of time that it represents, the state being in a region, then it can be replaced with a simple relationship like that. So all of this is replaced with each state must be in one and only one sales region. In our conceptual modelling technique, the one I've adopted, this arrow means that the state can change which region it is in over time, and that the knowledge of that, if you like, the changing of those, which region the state is in over time, is an inherent part of the meaning of this sort of model. So you can see how much simpler things get when you replace the intersection entity, which has a time period and nothing else in it, with a very simple relationship here. Okay, so now let's have a look at how you deal with removing time which has been used to track the history of change to an attribute. Here's a conventional data model that's been used to deal with the change in someone's salary over a period of time, and you can see we've got two entities, the employee, and there is a salary entity which tells you the value of the salary from one date to another for a given employee. So if you like, the collection of salary entities tracks the history of the employee's salary over periods of time. Now again, when such an entity has been put into the model simply in order to track the history of a particular attribute, in this case the attribute was probably salary, then it can be replaced quite simply with an attribute of salary in the related entity. So the attribute in the modelling technique that I've adopted here simply replaces that. Semantically, what this means is that an employee will have a salary at a point in time, but that as that salary changes over time, the model, if you like, automatically assumes the semantics that the salary will change, and you'll know what it used to be. In summary then, really there are two major ways in which you can remove time from a model to give you a much simpler and easier to communicate model. The first is where an entity exists purely in order to track the changes in a relationship over time. And what we're doing here is we're replacing this intersection entity with a relationship between the original two entities that it related. And then the second case we looked at was where an entity has been placed there simply to track the history of an attribute over time, and we're replacing that with the attribute itself, because the semantics in the modelling technique that I'm adopting here for conceptual modelling are that whenever you have an attribute or a relationship, the implied semantics are that although they only have a single value at a point in time, over a period of time they will change.